Hello, my friends. In this first video, I'm gonna target one problem of one session. It's the session of 2019, the first session. Why did I pick this session? And which problem did I pick? I picked a regular horizontal elastic pendulum. All right, so it's a regular horizontal elastic pendulum where you actually have an horizontal pendulum and you have some graph skills. As you can see, this problem should cost you around 20 minutes. And I assume you're gonna have 3 problems as long as this one in one full exam. All right? Now, how about we do some quick review about everything related, everything you should know for a horizontal elastic pendulum before we proceed. So the first thing you have to think when starting a mechanics problem is to start by discussing which is your system, okay? So in this case, if I go back to my problem, my system is the block of mass M and the spring, okay? This is very important to state your system. Otherwise, in some of the problems you will encounter later, you will see that probably you're going to have one system or two, and you'd rather pick which one you want to focus on. Then you need to name your reference. And by reference, I mean the reference for height equal to 0. Like, for example, in this case, they actually tell you, it should be written somewhere. For example, I'm going to take x prime OX to be the reference for height. Sometimes they write it for you and sometimes they don't. And if they don't, it's okay. Yeah, it's written here and probably I can highlight it. The horizontal plane containing G is taken as reference level for gravitational potential energy. So in other words, all the problem is a horizontal problem. It's going to happen on this horizontal line, and on this line, the gravitational potential energy is actually equal to 0, so you're not going to take it into account. So step number 1 of starting your problem is write the system, write the reference. Then obviously you have no friction, mechanical energy is conserved, and usually this is stated in the problem. For example, like in here, they would say, let me see, write, establish, deduce. It should be written somewhere, okay? I'm gonna find it for you and we're gonna highlight it very well. So now your job is to write the mechanical energy. Okay, how can we write the mechanical energy? By the way, by definition, what is mechanical energy? Mechanical energy is kinetic plus potential, isn't it? So kinetic in my case is gonna be half mv squared. What about potential energy? How many types of potential energy do I have? I always have mgh. In my case, my mgh is equal to 0. I can simply write it down and say this is equal to 0 because we just picked our reference to be along this horizontal line. And in the case where I have a spring mass system, I need to add the half kx squared, and this is key, right? Now that we just said that ME is conserved, and conserved means constant, I'm gonna do the derivative of ME with respect to time, and this one is gonna give me 0 because the derivative of a constant is 0, okay? Now your job is to do the derivative of this guy, okay, and the derivative of this guy. All right, let's see. The half is gonna be half because it's a constant multiplied by a certain function. M is also a function, a constant. Now v squared, v is a function of time. And what is the derivative of u squared? It's actually, so the derivative of u squared is actually 2u prime. Is it right? So remember, u is a function. It could be something like 2 sine 2t plus 4. So it's a function of time. So I'm going to write here 2v prime. And the same thing is going to happen for this guy. It's going to be half k 2x prime. Okay? So this is a general review before we starting the problem. By the way, if I change the color of my pen, I'm gonna probably pick green. I'm gonna say that, remember, v is by definition the derivative of x, okay? And v prime will be x double prime because I want everything to be written in terms of x. Back to my yellow pen, I'm gonna, or probably orange, I'm gonna cross out the half with the 2. I'm gonna cross out the half with the 2, okay? I'm gonna write the equation again. It's gonna be m, v will be replaced by x prime. Again, the velocity is the derivative of x is the position is a function of time as well. This is x double dot, okay, plus I have k, and this is x and x prime, and all that is equal to 0. Then I have the right to remove the x prime because it's in both sides of the equation. On one condition, I should write that x prime is different than 0, okay? So here in this case, and I can divide by m as well, and I will end up with x double prime plus k over m x is equal to 0. And this is a differential equation that governs simple harmonic motion. What is simple harmonic motion? Simple harmonic motion is a motion of back and fro around a certain equilibrium position. It's characterized by being periodic. It has a constant period. It's also interesting because the acceleration, which is x double prime, is proportional to the position x, and it's opposite to it because you have a minus sign if you write x double prime to be equal to negative km over x times x. Also, this differential equation, if you look at it very well, and let me have a thicker pen as well, this term is the angular frequency squared. So in other words, you will say the angular frequency squared is k over m. Okay? By the way, the angular frequency is 2 pi f. So by simply finding the angular frequency, you can find the regular frequency. And by finding the regular frequency, you can find the period. And this is very important and it's easy. You can take it from the equation. So every time you have a spring mass system, you need to start with all this. And every time they're going to ask you about each and every step, it's great to know. Before we start the problem, let me state a bit the units. K is the spring constant of your system. It's gonna be in Newton per meter. The mass, the SI unit for mass is gonna be in kilogram. The SI unit for W, which is the angular frequency, is rad per second. Okay, frequency is hertz. Some people say it could be anything like turns per second, and the period is gonna be in second. Okay, now let's see how we can proceed with the problem. This is the first part of the problem. I'm gonna read it quickly with you and we're gonna break it down and see what they want. But basically, they're simply discussing the problem and they say this is the origin of the x-axis, and this is very important. I'm talking about point O. Yes, so, and the very important thing to highlight is what happens at time 0. At time 0, the abscissa of G is x0 and S is launched in the negative direction with an initial velocity v0. Okay, so at time 0, x is equal to x0 and v0 is equal to v0 and v0 is negative. So if I need to write it well, it should be somewhere in this region. How do I know it's in this region? Because x0 is positive and v0 is negative, meaning if you release it, it's gonna stop moving in this direction, in the negative direction. By the way, this is the positive direction to the right, okay? Time 0 is very important to know many different kind of like the phase 0, and you're gonna see in a moment. Question number 1, write and at any instant t, so in function of time, the expression of the mechanical energy of the system. So they already told you what the system is. So you can start your problem by stating my system is oscillator Earth or spring mass system Earth. And they want the mechanical energy to be in terms of x and m and k and v. So in this case, you can simply say for number 1, that the mechanical energy is kinetic plus potential, and you can replace kinetic by half mv squared, and potential is going to be replaced by half kx squared. This is the elastic potential energy. I'm going to simply say that the mgh is going to be equal to 0 because we already stated the position of 0 height. Okay, Now they want you to establish, and let me pick highlighter, establish the second order differential equation. This is the differential equation we just did. In other words, you're supposed to start by stating no friction ME conserved. You already wrote the mechanical energy, you do the derivative, and this is exactly what they want. They want you to establish this. By definition, establish means you're supposed to prove it, you're supposed to derive it. So you're gonna write all this until you reach the differential equation. So the question is, establish the second order differential equation. Okay? This is the official answer. If you write the mechanical energy that we just did, you take half a point out of 7. And then you're supposed to write no friction, mechanical energy conserved, so ME constant, then the derivative is 0. And then you start doing the derivative of this equation. And you replace V by X prime and V prime by X double prime. And you can say X prime is different than 0 or equal to 0 is rejected. And this is exactly what we wrote in here. You see it? Otherwise, you cannot cancel it out. And this is the differential equation. And you will be given 1 full point for this one. All right. Now, what is your second question? Like second set of question. Deduce the expression for the proper angular frequency W0. To find W0, back to our formula sheet, everything you have here, and I'm actually here, everything you have under the X or close to X is W squared. How do you find W? You say this is W squared, hence W equal to, and you're gonna write the equation. So I'm gonna simply write that W is the radical K over M. In this problem, they're calling it W0 because it's the proper angular frequency of your system. So done with item 3. Then they want you to write the solution. So let me read it. The solution of the obtained differential equation is this. They already told you what the solution is. They say xm and w0 and phi are constants. They want you to write the expression of v. All right? We already know that v is actually x prime. And we wrote it in the formula sheet. It's the first derivative of the function x. So your job is to do the derivative of this guy. Okay, so how do we do the derivative? Xm is a constant, so I'm gonna write xm. What is the derivative of sine? It's cosine. So I'm gonna write cosine and everything under the cosine, w0t plus phi. Okay, and then I'm supposed to write the derivative of what's inside the cosine. w0t plus phi, the derivative is w0. And this is the answer for question number 4. Write the expression of v in terms of xm, w0, phi, and t, and it's already done. Now they want you to write the expression of x0 and v0 if in terms of. All right, how can we do this? How can I find x0, v0 in terms of x, w, and phi? I don't actually know. What is the definition of x0? Isn't it x at time 0? How about we take the x equation and I replace time by 0? What is v0? Isn't it the velocity at time 0? So we take the velocity equation and we replace time by 0. Okay, so I'm gonna take this slide and copy paste it here. So now I can create some extra space for us. And yes, and probably solve what we already just said. So let's see, I'm gonna write the x equation, x0, I'm gonna replace x by x0. xm is a constant, so it's gonna stay. And instead of writing sine omega 0 t plus phi, t is 0, so it's gonna be sine phi. So this is what is remaining. Now, how do I find v0? Back to the previous slide, it's xm w0 cosine phi because this guy is gonna cancel out because time is equal to 0. So v0 is gonna be equal to xm w0 cosine phi. Now let's read the question again. Write the expression of x0 and v0 in terms of xm sine. All right, so I think it's done because we wrote the expression of x0 and we wrote the expression of v0 and it's over. Now they want us to deduce this. In other words, they want you to find a relationship between x0 and v0. How can I find a relationship between these two? How can I relate them? My students know the answer very quickly because they already learned this and they have it somewhere in their libraries. The only way for you to relate to equations where you have sine and cosine, you actually have two methods. Method number one is to say sine over cosine is equal to tangent. Method number two is sine squared plus cosine squared is equal to 1. That these are like very famous identities. Since there's no phi in the equation, I'm not gonna use tangent. I'm gonna use sine squared plus cosine squared is equal to 1. Sine squared is this guy squared divided by this guy squared. And cosine squared is this squared divided by all this squared. So let me try to write it down. So x0 squared over xm squared. So that's the sine function squared. Plus now the cosine function squared is v squared divided by xm squared, w0 squared. All this is equal to 1. Now how do you find xm? You factorize it out and you will end up with this equation. Try it. We're done. So this equation will be simplified to give you this one. Right? Now they want you to use document 2 and 3 and probably it will be awesome if I can do this and create a new slide for extra space. Yes, and I'm gonna delete all this. Okay, now what do they want in question number 7? Question number 7, an appropriate device traces x and v. So this is the graph of x and this is the graph of v. And every time you see graph skills, I want you to chill because graph skills will give you a lot of very easy questions. So these are like bonus questions and it's very easy to learn some skills, some graphical skills. So you have documents 2 and document 3 respectively. Specify the type of oscillations. All right, how many types of oscillations we have? So in general, what are the types of oscillations? Okay, so let's try to name some and let's try to pick from these oscillations, from these types. Type number 1, you can say free oscillations. And I mean by free oscillations, nobody's pushing the system. You release the system and it's gonna go. We can think of damped oscillation. And by damping, I mean friction. Free oscillation that could be undamped and free oscillation that would be damped oscillations. So let me write also free oscillations that are actually damped. And by damped, friction. So let me write friction for you to keep that in mind. So undamped, you say no friction, okay? In this problem, we're only dealing with free oscillation because nobody's pushing my system. The system is oscillating with its own proper angular frequency W0. W0 means proper. Nobody is forcing the system to go in any specific frequency. So obviously I need to pick between undamped and damped. So is it undamped or damped? Looking at the oscillation, you can see that this is the amplitude and the amplitude is constant. The amplitude is not decreasing with time, so no friction. And we already wrote at the beginning of the problem, and it was actually here, no friction, ME is conserved. So yes, we're dealing with a non-friction problem. So I'm gonna pick this answer. It's undamped. It's free oscillation with no damping. That's the type of oscillation. Now indicate the value of x0, v0. x0 by definition is x at time 0. And this is where it is. It's the y-intercept. So you would say 10 centimeters. What is v0? It's v at time 0. So it's here. It's the y-intercept as well and the v-axis. What is xm? By definition, xm is the amplitude, and this is the amplitude. like 25 centimeter. Please do not forget the unit. What is Vm? Vm is the maximum velocity. It's also here. So it's the peak and the Vt graph. And they already told you Vm is the amplitude of V. Yeah, so now let's check the answers. So they already said that this is the differential equation and W0 squared is everything under the X. Fair enough. They did the derivative and this is what we did. They wrote the X0 equation, the V0 equation. Then they wrote sine, cosine, and they used this famous identity. And they wrote, they plugged in the values, this instead of sine and this instead of cosine. And they wrote xm on one side or factorize it first, and eventually they got the final answer needed, and they said free undamped mechanical oscillations. In my answer, I did not mention mechanical oscillation, and we know obviously that this is mechanical, but why not say it? Because in the electricity part also you have oscillations, so you can add the word mechanical. Now we said x0 is 10 graphically, v0 is given, and this is xm, this is v0, vm, and you can see how many points you can have. So if I were you, I would repeat the video later on and try to solve the problem myself. Now we still have some extra set of questions. Deduce that W0 is approximately equal to. How can I deduce? When they say deduce, they mean deduce from item 7. And item 7 is all related to the documents, which means we need to find W0 from the graph. How can I find W0 from the graph? Back to our formula sheet. We know that W is related to frequency and frequency is related to period. And graphically, I can use the graph and probably I can, I don't know, crop this graph and use it in my second slide. Okay. This slide because I need extra. Yes. Keep it next to me and let us find the period. How do we find the period? Very easy. You should know this from middle school. To find the period, I find the time taken between two troughs, or the time taken between two peaks, or the time taken, and let me use a very thick highlighter, actually dark highlighter that is not so thick. I'm gonna find the time between a 0 and the third 0. So I'm gonna count 1, 2, 3, 4, 5, 6, 7, and 2 halves, which would give me 8 divisions. Okay? But how can I tell 8 divisions is how many seconds? Because I cannot see how many seconds is there. Let me revisit. I cannot see any graduation on the time axis. So apparently we cannot use the graph. I know it's 8 divisions, but I cannot tell each division. I don't have a scale for that. I need a different method. So probably go back to the fact that I need to use that W0 is radical K over M. Are we given K and M? Let me check. Back to the problem itself. Probably this is a zoomed in picture. I don't have K, neither M. How will I be able to find W0? Do you have an idea? How can I deduce that? I have an idea. Didn't we say, okay, this is awesome. Didn't we say that this is the equation of V0, right? And everything, actually, this is not the equation of V0. I want the general form. This is the general form. So this is, let me pick blue. This is the equation of V. And everything in front of cosine is actually the amplitude. And we just discovered that the amplitude is, where is the amplitude? It's 5 meters per second. So all this is gonna be 5 meters per second, right? And we found that xm, which is 25 centimeters, be careful to be converted to meters. You have xm, you can find W0. And you're too lucky because they actually gave you the answer. So you just have The answer would help you because probably some of you would forget to convert centimeter to meter. You're lucky. Now we repeat the same experiment by replacing the block S of mass m by another block of mass f m prime. And probably m prime is bigger than m or smaller than m. We have no idea. The new frequency is half the old frequency. That's something to think about. So I'm going to write that W0 is already given by radical K over M. You know, I don't write radical. Let me write W0 squared. So W0 squared is K over M. Okay. Now, what is W prime squared? It is K over M squared, M prime. I know the relationship between W prime and W0. So I'm going to replace this one by W0 over 2. I'm going to overwrite it probably with purple. So this is W0 over 4. Why is it over 4? Because I'm doing squared for W0. So it's W0 squared over 2 squared. Okay? What else do I know? I know M prime. W0, I already found it, which is here. I already wrote the relationship that they want. They want W prime in terms of, it's already written under the purple. Deduce the values of K and M. Knowing M prime, I can find K, and knowing K, I can find M. So the problem is over. So let me check. W0 was found using the big radical equation, not our method. They use this equation to find W0. And why not? You have XM, you have X0, you have V0, you can use it. Also, they show another method. You see the OR? This is my method. Use VM to be W0XM. This method was actually here by stating that this is the maximum amplitude of velocity. Everything under the cosine is the maximum amplitude, yes. So finding W0, and since you have the final answer, you don't have to freak out. This is the equation we wrote, but we wrote W prime squared. And then knowing this one, they found K and then they found M, right? And the problem is easy. So if you have any question, please comment on the video and I can give you any feedback you want. So this is session 2019-1. It's exercise number 1. I picked this problem because this problem deals with a simple horizontal elastic pendulum with a bit of graph skills. In my next video, probably I'm gonna take a horizontal elastic pendulum, not using graph skills, using some other methods to follow. See you. Thank you for watching.